Morning, guys. Well, this is it. This is our last official lesson of data. So very proud of you. We've done it. We've done it together. You've worked hard. I can't believe we made it, but we did. Here we are. So before we do our colored sheet, I attached a PDF that's a formula sheet. So if you were writing this test in class, you would have received a formula sheet. Okay, so can you do me a favor? Let's get out the formula sheet. I just want to go through a couple things on the formula sheet. I mean, you have your notes to do the test, so you don't need it, but let's just kind of pull things together. The first formula and the third formula are our Bernoulli trials binomial distribution formulas. Okay, that's your Bernoulli, that's your quickie expected value. The second and the fourth formula are our weighting times geometric distribution formulas. Our fifth formula is our Poisson distribution formula. And remember, with Poisson, there's a time element, and we'll put in the word in brackets, we'll put the word per, and there always is an average. Okay. The last three formulas, I haven't forgot about this guy, don't worry. Okay, I haven't forgot about him. But the last three formulas are the sorry, my mistake. Are the normal approximation to the binomial distribution formulas. And remember, with that, there's a step 1, a step 2, and a step 3 process. Now, the formula that I sort of skipped over, and I'm going to highlight it, is the formula for a term for the binomial theorem. Oops. I don't want that to... And I'm having some spelling issues on our last lesson. And the important thing to remember, okay, is that your R is the term number minus 1. Your term number minus 1. So first and third are Bernoulli. Second and fourth are geometric weighting times. Fifth is Poisson. The sixth one is our term formula for binomial theorem. And remembering that your R is the term number minus 1. And then the last three formulas all deal with the normal approximation. The only other thing I want to throw on our little formula sheet is our expected value, probability distribution chart. And that's way, way back from our very first lesson. And it's an outcome probability chart with a capital E formula. Now, don't worry, we're going to go through the classic colored sheet, just like always. I just wanted to do this because in a normal classroom setting, you definitely would have been given this for the test. Okay, in a normal setting. Okay, so I'm going to pull my colored sheet out. Yay, the last colored sheet. And I'm going to call this probability distribution, because that's our unit. And we're going to talk about, typical colored sheet, everything that we've done. So the first day, a probability distribution is a chart or graph, and it displays all of the possible outcomes and their associated probabilities. So it's the classic outcome probability chart that we're familiar with. And what goes with it is the classic expected value formula that says, hey, I'm going to sum up all of the options from the first option to the last of the outcome times its associated probability. And the expected value is the outcome we would most likely expect. Now, remember, the big thing that I stressed with this particular unit is the whole idea of it being an average. Okay, the whole idea of it being an average. Now, we had a series of different types of questions that I could actually give you on the test. We had a game example. Remember the basketball example? We had a combo example. We had one in our notes and one on the assignment. We had a tree diagram example. We had a lottery example. And we had a side with area and perimeter example as well. And I think actually in your textbook, your homework, that 15 and 16, there was also a selection example. So in most cases on your test, there's easily 2 to 3 of these. Okay, easily. Okay, now the second major concept, after we spent a couple days on this, you had a nice assignment, is the concept of a binomial distribution. And a binomial distribution is also called a Bernoulli trial. And there are 2 outcomes. That's what makes it a special probability distribution. There are 2 outcomes. Now, what goes with this is a beautiful formula. Remember, I said that I don't have the call letters memorized. I have the words memorized. Number of trials to number of successes. Probability of success to the number of successes. Probability of failure to the number of failures. That's your Bernoulli formula. What also goes with it is a really quickie type of expected value formula, if it's a Bernoulli question, where you take the number of trials times the probability of success. So let's kind of write this down. Number of trials, number of successes, probability of success, probability of failure, and number of failures. just so that you know when you're referencing it later. Okay? Now, there's a series of questions that go with Bernoulli as well. Dice chart. Okay, we used the dice chart. Defective products. I think we did a couple of those. The words exactly, at least, at most. Just a variety of series of words. And I would probably, again, with Bernoulli, expect for sure 3 questions. I think that's fair. So the first 2 topics could account for about 6 questions on your test. Next topic was a geometric distribution. And remember, I called geometric distributions waiting times. And the idea with the geometric is how long do you wait for a success? And that's really, really super important, because with a geometric, when I write down the formula, what's different about a geometric is right here. It's the probability of failures before getting the success. So you gotta be really, really careful with these. I'm being very truthful. And the formula is probability of success times the probability of failure to the number of failures. And again, there was also a quickie expected value formula. And that quickie expected value formula was probability of failure over probability of success. But again, this was one of those ones that you had to be careful of, because this gave you the expected number of failures. So if you think back to the note, this is the one that we always added 1 to our answer and our therefore. Expected number of failures before a success. So again, I'm going to heed the warning. I want you to heed the warning. Be real careful with these. I would say 2 questions would be my good guess. So expected value 3, roughly, right? Binomial 2, geometric 2, and then we got into our binomial theorem. And really and truthfully, I guess with binomial theorem, the best way of, putting this on our colored sheet is with an example. So I'm going to do a quick example. And I guess we can just do the whole thing, right? So when I look at the exponent, the number of terms is the exponent plus 1. So the number of terms is going to be 4 full terms. Okay? Now, remember, my first term is my descending power. So my descending power is going to be x cubed, x squared, x to the 1, x to the 0. My second term is going to be my ascending power, negative 2y to the 0, negative 2y to the 1, negative 2y squared. Sorry, that's kind of messy. And negative 2y cubed. So negative 2y to the 0, negative 2y to the 1, negative 2y squared, negative 2y cubed. And then remember, we spent some time learning that that coefficient is really like a combination. 3 choose 0, 3 choose 1, 3 choose 2, and 3 choose 3. And we figured out, that at first we could use Pascal's, but we didn't need Pascal's, we could just use the combination. So hold on, let's go slowly. 3 choose 0 is 1. X cubed is x cubed. Anything to the exponent 0 is 1. 3 choose 1 is 3. X squared. Negative 2y to the 1 is negative 2y. 3 choose 2 is 3. X to the 1. Negative 2y squared would be 4y squared. 3 choose 3 is 1. X to the 0 is 1. And careful, negative 2y cubed is negative 8y cubed. So x cubed minus 6x squared y plus 12x y squared minus 8y cubed. Should you expect one of these? 100%. Could it be harder? It could be. You did much harder ones than this. Now, the other thing that we did in the binomial was the formula for the general term to get me a term value. And that's the formula that was on your formula sheet that we just looked at. And remember, we discussed that our formula was very similar to the Bernoulli formula. A was your first term. B was your second term. This n right here is your term number. The R was your term number minus 1. Okay? And n was your exponent. So again, in a testing situation, guaranteed you're getting both types of questions. Very similar to what we did in the notes, very, very similar to any of your work that you did. So right now we're at what, 3, 6, 8, 10 questions roughly, kind of standard. Now, next topic, normal approximation to the binomial distribution. And the key here is, when do I use this? When the heck do I do this? When direct Bernoulli requires too many iterations, or when reverse psych requires too many iterations. So we talked a lot about this during the lesson. Like, you bring in the normal when you get a question that direct Bernoulli would require you to do too many iterations, and reverse psych would require you to do too many iterations. This is step 1, step 2, step 3. So step 1 is the test. NP better be greater than 5, and NQ better be greater than 5. Step 2 is to calculate your mean, which is your NP, and to calculate your sigma, which is the square root of n times p times q. Step 3 is to actually use your z-score formula. And you know as well as I do, the tricky spot is that x. That x better be decimally. It can't be a whole number. It can't be discrete. It can't be, anything that would be a discrete value. It'd have to be a decimally answer. And remember, this is where I drew the number line. Do you remember my number line? And we had the choice. That's what you got to be careful of. I'm thinking about 2 questions. And you know that I've already told you anything with the word between is a normal approximation. So I'm sort of telling you, you're getting a between question, right? Okay, the very last one is a Poisson distribution. Sorry, I didn't review. How many questions are we looking at? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looking good. Looking good, right? 12, 13, 14 questions. And a Poisson distribution is the probability over a fixed period of time. And that is the key word. There's that time per day, per minute, per second, per hour. The formula is kind of wonky. Remember, the formula was your average to the number of occurrences times e to the negative average all over your absolute number of occurrences. So let's recall, x bar is your average, x is the number of occurrences, and e is the element of 2.71, I think 28. Okay? So again, I had already kind of told you this. Probably expect 1. This is just a little fringe topic, and I don't want you spending a lot of time on it, but it's definitely a topic covered in university. Okay, that's why I introduce it, so that you guys have heard it. So if we're getting ready for the test, we're thinking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 questions on the test. Sounds normal. Guys, thank you. It's been a pleasure. I've missed you like crazy. This wouldn't be the way I would choose to do things, but I couldn't have asked for 2 better groups. You've been spectacular. Good luck on your last test. I'm really proud of all the work you have done in these weird and unusual times. I hope it's been good. Keep your notes for university. Keep everything, because I know it's well used. Many people have told me in years past this stuff is all well used. Okay, it's been my pleasure. I wish we were together writing the exams together so I could give you all big hugs, but just envision virtual hugs, okay? Take care of yourself. Good luck with everything. Thank you.